Inequalities. This was section 1.7, if you want to kind of know where we're at in our studies. So we had different types of inequalities. The first type we're going to study or review is the linear inequality. So you saw those pretty much like any other linear equation. You simplify by reducing with the LCD if necessary if there's a fraction. You gather your like variables and so on. Distribute. The only difference is if at any point you divide or multiply by a negative sign, it flips the inequality sign around. So we'll be watching for that. Okay, so I've distributed the 4. Then I'm going to bring the 20x across the inequality, just like crossing an equal sign. It will change its sign to minus 20x, and that gives me 4x. The minus 24 constant to the right side makes it plus 24. The inequality is not changing, and then that's negative 16. I'm going to divide by a positive 4, so the inequality will not be turning around. Just leave it as is. Now, it does give me a negative answer on the other side, but I did not divide or multiply by negative, so the inequality did not change. So this says in interval notation, or also by the graph, I want to show you that as well, that x is all the numbers greater than negative 4. So say that's negative 4, it's every number, decimal, fraction, integers, whatever, any real number greater than negative 4. And we use a parenthesis because there is not a line under that, so we're not including the negative 4. Okay, number 31, it's still linear, but we have 3 parts to it. We have an x in the middle, so we have 2 different sides that we're keeping balanced as well. So I'm trying to work from the middle part and get x alone in the middle to see what 2 numbers it's between. So where I have a plus 4, I'm going to minus 4 from all 3 parts. Now listen, minusing 4 does not flip the inequality. It's only if you divide or multiply by a negative. So simplify that down by minusing 4 from each segment. Now, next thing is I will need to divide by negative 4 to clear that out. So negative 4 divided by negative 4 makes positive x, and then I do that to each part, which will flip both inequalities. It'll look like that. So this says x is between negative 2 and negative 6, with the negative 6 included, so it should have a bracket on it. So on a number line, and notice the numbers aren't in the right order anymore, so you have to turn those around. Negative 6 is smaller than negative 2, so get those in the right order, and then it's greater than negative 6, but less than negative 2, or between those 2 numbers. In interval notation, that would be negative 6 to negative 2. Okay. Number 32 is a quadratic inequality. Now, when we do quadratic inequality and then number 33, rational inequalities, those are the ones where once we get the answer part, we're not done. We have a follow-up part where we have to check regions. We have to actually take a test point from each part of the number line. So just be aware of that. On the linears, you did not have to worry about that, but on the quadratics, you do. Quadratic and rational. Step number 1, get it equal to 0. Factor it just like you do other quadratics. Set each part equal to 0. You get boundary lines of negative 3 and negative 4. But like I said, you don't know what parts are solved for. Those are just the splitting points on the number line. That is not the final answer. It might be the area between, oops, should have said negative 4 is the smaller one, right? You don't know if it's this region here, the part between, or the part over there, and all those combos will be choices, so you have to be sure that you know which part. So you take a test point, like something over here, maybe negative 5 in this region, and see if this needs to be shaded. You can check it back in the factored form or any of the former forms. They're all equivalent anyway. So negative 5 plus 3 times negative 5 plus 4, that's negative 2 times negative 1, which makes that positive 2. 2 is not less than or equal to 0, so that is not a true region. I should not shade it. Now, I know we've kind of learned that it's every other one. If we're real sure, we can say, well, it's probably this one and then not this one. And to save time, I'm just going to go ahead and say this region works, and then taking something from this region, you find out it doesn't work. There is a line under it, so I use brackets. -4 to -3. Okay, number 33. Okay, another situation where you wind up checking regions. The regions you check are found by setting the numerator and the denominator equal to 0. But first of all, you have to get your fraction into just one fraction, I should say. So the 17 needs to be brought across the line. Makes it -17. And then you have to get like denominators and combine that into one fraction. So right now that is over 1. So this is the LCD I need to use. So this fraction stays as is. And this fraction is times by this extra -3x plus 8, so I times the numerator by -3x plus 8. Now that I have like denominators, I'm allowed to combine across the numerator. So 5x. Now listen, don't forget to pick up your subtraction sign. It'll mess up your whole answer if you don't. -17 distributes, becomes plus 51x, and -17 times positive 8 is -136. All of that is over now that common denominator. All right, then combine your like terms. We have 56x's and -136 over -3x plus 8. Okay, once you get it into one fraction, now listen, your problem may start out like this. You may already have it equal to 0. If so, that's kind of a gift, so it makes it easier and more time efficient. If it's already equal to 0, then you've skipped all that step you won't have to do, right? But you gotta get it equal to 0, and then you take your fraction, the numerator, set the numerator equal to 0, and set the denominator equal to 0. Solving each part will give you your boundary lines. So this one gives me a boundary line of 136 over 56. I'll need to reduce that. And then the second one gives me a boundary line of positive 8/3. That reduces, let's see, into the 17/7. 136 over 56 is 17/7. And I don't know why I put 6 when I said 7, but okay. Reduces 2. I guess 8 goes into both of these, 8 into 136 and 8 into 56, so it reduces down. So you get these two boundary lines. Which one is smaller? 17/7 or 8/3? I'm going to have to use my calculator. 17/7 would be 2 4/7. 8/3 would be 2 2/3. I'm still not sure which one's smaller. So let's see. What is 4 divided by 7? Is it smaller? I could get like denominators, right? That is
17/7.
17/7 is a smaller one.
Like 2.4 and then 2.4.
Okay, this one's 2.6. It's
Yeah.
bigger. Okay, thank you. So 17/7 goes on this side, and 8/3 goes on this side, because you got to put the smaller one on the left side to get them in the right order. And then we check the regions to see which regions work. Now, to find the number between those, that's going to tax my brain even a little bit more. So I probably would avoid that region. I'm going to check over here in the 0 region, right? All this area, well, that's positive. 0's back here, isn't it, guys? Okay, 0's over here in the first region. And so I'm going to use that as my test point. It's not a boundary line. Those are my only two boundary lines found from the numerator and denominator. This is a test point to see if this region is true. So I put 0 back in the original problem and check it out. 5 times 0, -3 times 0 plus 8, is that greater than or equal to 17? And that is 0 over 8, which is 0. 0 is not greater than or equal to 17. So that test region failed, do not shade it. The I'm going to assume the number between those two, which will be like you could use 2.5 and plug it in and check it. But I'm going to assume it works. And then I could check this region, like take a test point like 3 something beyond 2 2/3, check it, and then it should not work. All right, so what I want to talk to you about is once you do determine the region that works, whether to use parentheses or brackets, because you could have come through all of that battle and still miss it on this one little detail, so I'm really worried is, there's a line under it, and I know I've told you lines mean to use brackets, but we had that one exception to the rule. Whatever makes the denominator equal 0, we have to put a parenthesis around it anyway, no matter if that's there or not. We still use a parenthesis on the 8/3 part. So parenthesis this one, whatever makes the denominator 0, we cannot include that as a solution, but use a bracket if there's a line under it on the other boundary. Okay, so the final answer is bracket 17/7 to parenthesis 8/3, just those small little region. But actually, how many numbers are there between 17/7 and 8/3? I say it's a small region, but how many answers, numbers? There's still infinite values in there. You could always find infinitely small pieces in there. All right, we'll go ahead and stop it.